Hi, today we are going to talk about circular motion. In order to track an object in a circle, I want to introduce the first physical quantity is position vector. At any particular moment, the position vector is given by r. By putting the circle into a coordinate system, r vector have components. Thus, we have horizontal component r cosine theta and vertical component r sine theta. Based on that, the position vector r can be expressed as shown, where I is the unit vector in the x direction and j is the unit vector in the vertical direction. However, the expression theta is always changing. So, to capture theta, we have used another physical quantity called angular velocity. The definition of angular velocity can be compared with linear velocity, that is, number of radians per second. We use a Greek letter omega to express this physical quantity. The equation is also similar with the linear velocity. In linear velocity, we have displacement over a time interval. Well, in angular velocity, we have similar formula, that we have angular displacement over a time interval. Yes, the theta has another name, that is angular displacement. Back to the position vector. Theta can be expressed as omega t. The reason that why we don't have the delta is because we normally choose that the horizontal line as the initial position. Here is an example of position vector. We can tell immediately that it's a uniform circular motion. It is because both r and omega match up. Now let me tell you more about angular velocity. In uniform circular motion, we normally use del theta over del t as our equation. That is because when the object goes over the circle, del theta is equal to 2 pi, and time we call a period. We use capital T to represent period. It indicates time for one revolution. It is a useful equation in uniform circular motion. For some non-uniform circular motion, we can use instantaneous angular velocity that equals to d theta over dt, that we will talk about later. Another thing you need to pay attention is its unit. Based on its equation, we have already know that is radians per second. But there is another one you will see in the exam, that is RPM, which indicates revolution per minute. For example, if a ball moves at 20 RPM, how much radian per second? We use 20 revolution per minute times 1 minute 60 seconds times 1 revolution 2 pi radian. That's got the result is 2/3 pi radian per second. It is okay to leave pi here because it's an angular quantity, but eventually we are going to transfer to linear stuff. So we're gonna time 3.14 here if you want to transfer to linear stuff. The third one is linear velocity. We sometimes call it tangential velocity because the direction is tangent to the circle. For uniform circular motion, the magnitude of velocity is constant. The direction of velocity is constantly changing. Here we can use a mass equation about the distance along the arc. Taking derivative, we got a relationship between the linear velocity and angular velocity. Recall the equation of angular velocity that's equal to r pi over t, and we put the equation into the relationship that got the linear velocity equals to r pi r over the period. It is easy to understand that r pi r is the circumference and t is time for a circle. It is in accord with the definition of linear velocity, that is displacement over time interval. That's all for today. Please join QQ group to find more resources and more lessons. Thank you for listening.